Good morning, I'm Jeff Chapman from Oak Ridge Associated Universities, and today we're in Providence, Rhode Island at the 51st Annual Meeting of the Health Physics Society. It is Wednesday, June 28th, 2006, and as part of the History Committee, we are interviewing a number of our prominent pioneers in health physics, and one such individual is Sandy Perle, who is here with me today. And I first want to thank you for joining us today.
Thanks, Jeff. I appreciate the opportunity.
I'm sure you do, and thank you very much. And with that, let's just delve right in and ask, how in the world did you get into the business of health physics and the science of health
Well, when I got into health physics, I had not a clue as to what health physics was. That started back in actually 1970. When I started at the University of Miami in 1966, I was in a pre-med program and major in chemistry and biology, and didn't really care too much for basic physics. And then there was the Vietnam War, and getting into medical school back in those days was a little bit more difficult because of all the people trying to get out of the draft. So I graduated with my 2 degrees in 1970 and did not want to go out.
Biology?
In chemistry and biology, with the pre-med and background. And I decided I didn't want to go out and teach, didn't want to do research, and I was speaking to an individual, and I was told, well, we can give you a free scholarship to get your graduate degree in radiological physics, and we'll pay your tuition, we'll give you a government stipend. It was under the old HEW program. And HEW, right, way back. This is, again, 1970.
Was this a deal, was what the
it was under the health and education welfare system. So I figured free education, free stipend, just got married. I said, don't know what health physics is, but it sounded good to me. So I entered it, and from 1970-71 was in the program, got my master's in radiological physics, and that's what got me started. First job was then.
Now, were you a native of Miami, or you moved to
Miami
from?
I was born many years ago in New Jersey. Moved to Miami when I was 2 years old. Basically, that puts me in as a native. But in between that, I went to military academy up in Indiana, a school called Culver Military Academy. The reason I went there, that was 1964, because I didn't want to go. I was living in Puerto Rico at the time.
Oh my! And
my father was in the building business and moved from Florida to Puerto Rico, and it was interesting. But after a while, I was looking for a little better education. So in '64, I went to Culver, and the reason I did that was I didn't want to go to one of the prep schools up in Massachusetts and wear a suit, which I still don't like to do, obviously. And decided military academy sounded pretty interesting. And Culver was ranked about number 3 or 4 in the country, you know, behind Andover and Choate and so forth. So I did that, went back to Miami, met my future wife at the university, and again, when I graduated from Miami in '70 is when I ended up in this program. My first job was to work for the state of Florida, more in the medical physics.
Up in Tallahassee?
In the Miami area, Dade County area, in Miami area. So I started with the state of Florida in '71 while I was finishing up my dissertation thesis program.
Which was in, what were you studying?
Radiological physics.
What specifically?
In the medical physics area, you know, X-ray technology, nuclear medicine, which really tied very well with the state of Florida, because I headed up the program. They were looking for a physicist to head up the inspection program. So I came in, again, you know, just right out of graduate school, and a little intimidating at first, but basically that's what I did. And I worked there for 4 years until 1975. Working for the state government is kind of nice, but they don't pay a lot.
Right, I understand.
So in 1975, I had dealt with a lot of the utility people. Basically, it was Florida Power and Light Company, who had just basically started operating 2 nuclear reactors in the Miami area, Turkey Point Nuclear. And they were in the process of starting up St. Lucie Unit Number 1 up in the central part of Florida on the East Coast. And I was involved from the state aspect in the emergency planning part of it. And the fellow who headed up emergency planning said, we have an opportunity here at the utility. So in 1975, I joined the nuclear utility and started to get involved more in the reactor physics part.
I see.
First 6 months working in emergency planning, I really didn't find that to be real exciting. Now we're talking about 1975 now, so it was very archaic back then.
Sure.
Simple little drills and so forth, you know, this is pre-79, so it was pre-TMI. But after about
who in that program was your mentor?
Well, the fellow who got me over there then was Sam Kingsbury. Actually, Sam was a little older gentleman, but I had known him for those 4 years, and he headed up the emergency plans for the utility. So he's the one that first got me into the utility world. The corporate health physicist at the time was Harvey Story, who was also, I haven't seen him in a few years, he was also a member of the HPS. And speaking of HPS, as a graduate student, I joined in 1970, so this is my 36th year as a HPS member.
Fantastic. Fantastic.
So anyway, I joined the utility, and a lot of things happened there, but after about 6 months, I was asked to learn the dosimetry system, because the only thing I had any experience with dosimetry was the little Everline single chip TLD that we were wearing in the state, and that was my entire experience with dosimetry.
And it was a TLD.
It was a TLD.
In the late 70s.
It was a TLD because they had just transitioned off of film, which was a big dosimeter back then. So the utility had started up their program in September of 1975, and actually another individual who got me started in this is Randy Scott, who is a member of the HPS, who actually is here. He and I started the same day back in 1975. He was going to run the TLD system, and after 6 months I was asked, well, why don't you learn the TLD system here as a backup to Randy? Well, then Randy moved over to emergency planning, and then I started the dosimetry program for Florida Power and Light. It was an old Harshaw TLD system that one of the first people I had met in the industry from a commercial standpoint was Art Lucas, actually. Art was back with Harshaw at the time. And people like Art and Marco Moscovich, who was with Harshaw at the time, basically they're the ones that gave me all the knowledge about TLD systems. And I had studied John Cameron's book back in graduate school on TLD. I had the pleasure many, many years later of meeting John, and actually brought John out to California to give a workshop at our California chapter meeting. And so
this is later.
This is later on. Oh yeah, but this was back in when I finally met John Cameron. We're talking about in the mid to late 90s. I had never met the gentleman before, but I knew all about him.
Of course.
But I was given an opportunity a few months ago when the HPS newsletter was doing a series of who would you like to have known 50 years ago or 40 years ago, and I wrote an article for the newsletter, and of course John Cameron was really the one individual who, I mean, in the long run has had the most profound impact on my career, because I would not be where I am today without him having invented the use of TLD, not as a dosimeter, but per se as being used for personal dosimetry.
Was he a solid-state physicist?
He was a physicist, yeah. And if you've ever had the opportunity, he's passed on now, unfortunately, in the last year, but very, very knowledgeable and energetic individual.
We'll have to make sure we read the newsletter. Is the newsletter that you published this article in?
Yeah, I talked about, it was in the newsletter.
Okay, yeah, okay.
So basically, that's how I got into dosimetry. Again, one, I didn't know what health physics was, and I didn't know a lot about dosimetry. But in that 6 months in the end of 1975 is when all of this began.
When you started in this line of work, everything hadn't been solved by then. I mean, there's some ideas. So what were some of the big surprises? I mean, there had to be...
Well, we're talking again 1975, and at that time, Florida Power and Light, the only real system out there was the Harshaw type TLD reader, typically with a 2-element dosimeter. The government DOE labs, they were basically coming up with their own dosimeters, which were pretty much top secret. So from a commercial standpoint, it was Harshaw, which is why I got to know Art really well, and Marco and a few other individuals at Harshaw. But in 1979, when TMI occurred, what everybody realized was that there was not a lot of way to do dosimetry within the power plants. And Panasonic came out at that point, and they set up a system at TMI to do quick, real-time turnaround of dosimeters. Back in those days, most of the power plants weren't doing their own dosimetry. They were all relying on commercial outfits. After that is when the power plants started. Again, FPL was doing this in '75. A lot of the other plants started saying, you know what, we need to do internal dosimetry ourselves. So then we had Harshaw, and then Panasonic came out. The problem that most people had was, with the Panasonic technology, nobody really understood it, because the system was developed for the Japanese military, and they were only interested in gross detection of radiation. And at this time, Harshaw was starting to turn around and developing the 4-element TLDs, and they were getting, it was using hot finger type contact, and they started thinking about later on non-contact. So there was the TLD revolution was now in process. We at Florida Power and Light back in probably 1991 transitioned over to the Panasonic system. Not because of the technology per se, but it was more economics at that point. And so now you had a lot of the nuclear plants working with TLDs from Panasonic, but again, a lot of them didn't know how they ran. And there was a lot of, that started at Panasonic dosimetry conferences back then, and people started to learn more about it. But
so would you
during
say
these transitions where I started to learn more about the systems, again, working with Art and working with Marco and just getting more of a foundation. And of course today I've been, again, doing this for 31 years now. I'm not an expert, but I'm probably one of the few that's been out there as long, still doing dosimetry processing.
Right, so now after you left Florida Power and Light at some point.
1996, I left,
okay, so you were there
21 years.
Yeah.
I left Florida Power and Light probably about just when I was starting my 22nd year. I started again in September of '75, and I left in September of 1996.
And you left because you
Well, back in the 1990s, there was a lot of cost cutting going on. Energy was expensive. There was typically about a $500,000 per day fuel replacement cost for outages. The management philosophy was we'll do more with less. So the utility world in the 1992 started to do what they call, was downsizing, and then of course that became right sizing. You know, I guess what is right sizing? Well, it's where you can cut those who are at a certain age, a certain number of years experience. And I went through about 3 or 4 years of that. I saw my staff cut from a staff of 5 dosimetry technicians and a supervisor down to 2, and doing more type of dosimetry. So in July of 1996, I was given an opportunity to either stay with the utility and take a big pay cut, lower the level of my position, or walk away with 15 months pay. And I thought that 15 months pay was a pretty damn good idea. Yeah. And after about 21 years, I had enough of the nuclear mentality in the power plants. And at that time, I had known another person who has had a big, profound influence on my life, was Sandy Nemechek, who at that time headed up the ICN dosimetry program out in California. And we had done since our own dosimetry in the utility, extremity monitoring became more of a frustration than anything else. So we started to use ICN dosimetry for our extremity monitoring. So I got to know Sandy Nemechek, and every outage she would come in, set up a system, and we would do the monitoring, but they would provide the equipment. In 1996, when I left the utility, she sent me a note and said, "Hey, we may have an opportunity for you to come out to California." And I had no idea what the job was. What I did not know at the time was that ICN dosimetry had just bought, in July of '96, the Siemens dosimetry company from Siemens Medical. So I went out for an interview in July. At the same time, I was doing NavLab assessments for the government. So I'm still doing assessments of other NavLab accredited dosimetry labs that I've been doing since 1993. Let me step back one step. 1995, while I was still with the utility, I actually did a NavLab assessment at ICN dosimetry, not knowing that a year later I would be talking to them about a job.
Right.
And I did that with Jan Guzmano, who was at that time at Idaho National Lab. So anyway, we did the assessment. So in '96, I went out to do an assessment. I had just left Florida Power and Light. The next day, I flew to Palo Verde out in Phoenix, Arizona, and did a NavLab assessment. I didn't want to be waking up the first morning with nothing to do. So I started to do the NavLab assessment. And after the assessment, I flew to California, sat down with Sandy Nemechek, basically just talked about what I was going to do when I came there. Got back to the airport, called my wife and said, "This looks like I got a job." She said, "Well, what was the interview like?" I said, "There was no interview. It was just like, this is what we want you to do." I accepted the position, and the next day when the offer came through, they faxed it to my home in Florida, and I got on a plane the next day with a ticket, and that was in September of 1996.
Oh my, so really 30 years now in external dosimetry.
Yeah, well, 31 years, right, doing external dosimetry.
Where do you see this science going? What's the future? What's the future? I mean, this is a long time.
Well,
a career.
One thing that in external dosimetry that a lot of the power plants tried to push back in the 90s was to move away from TLD dosimetry. One, because of the quality assurance programs, the time that it's a passive dosimeter. And there was a big move about 93, 94 to go to electronic dosimetry. That was in its infancy at the time. And there were several companies making them. At that time it was MGP. And the power plants were using these as secondary monitoring, primarily because from a regulatory standpoint, American nuclear insurers who insured the nuclear power plants for Price Anderson and so forth, said you shall use two independent type of technologies. So they were wearing these electronic dosimeters that are real time. Energy response is not as good as a TLD, probably wasn't as good as a film, and now it's probably not as good as an OSL. Anyway, they were trying to move to that because now they can say we don't need a TLD, we just wear this electronic dosimeter and then we read it and we're done. Well, today the electronic dosimeters are getting a little better, they're more precise, but they're only accurate in the range of the calibration. So they have not replaced the TLD system. I'm biased, I've been doing this 31 years, I still think the TLD is the finest dosimeter out there because basically a person can take it, like yourself, walk into an unknown radiation field, and with the proper algorithm of the system, you will come up with a pretty accurate assessment of what kind of exposure they received, what type of energy and what type of mixture, whether it was photon, beta, neutron, whatever. Future, I think and we're looking at these things as well in our company, real-time dosimeters that will have a broad response to broad energies like a TLD, where essentially you can walk into a radiation area with little readers set up that basically you don't have to sit there and take out and read, but it'll basically use in infrared or RF or some type of force where the person just walks into an area, it recognizes who you are, it recognizes where you are, almost like a GPS, and it knows what kind of dose you have. And it can track you incrementally through your facility. Now this is probably going to be good for like a power plant, a DOE facility. Probably not as good for a medical facility. So I think real-time dosimetry is probably where people are going to go in the future. I don't think the real issue is the sensitivity of them because philosophically I believe that we're already too conservative in what we track. I don't believe the U.S. will move the way the Europeans have moved, where their dose thresholds have come down. I'd like to see the dose thresholds actually go up. There are areas where people probably don't need to be monitored. I think the fact that the industry puts so much focus on these little small doses gives the public the concern that they have about radiation in general. I mean, if these people are concerned about these 1 millirems and 2 millirems, well, the public has to assume, well, this must be dangerous levels. So I think, from a public perspective, I think the industry itself, and I include myself in the industry, probably have caused more of the fear that's out there today because of the way we treat radiation every day.
Interesting comment. Yeah, I agree with you, actually.
And I mean, we're in the business to move dosimeters, but I think you can put dosimetry on the people who need it. You can measure it more accurately. But let's stop giving the public the fear that radiation is going to kill everybody out there, and also get rid of the concept that these nuclear plants are just going to blow up. I mean, we had TMI, we had Chernobyl. Yes, some people did die in Chernobyl. Yes, it did cause some cancers in the area. But that kind of accident hasn't happened in the U.S. And the real result of TMI, and as you know, was that it was more of an emotional effect.
Sure.
Nobody had any type of exposure that caused any real illness.
Right, so absolutely. Next 10 years, what's Sandy Perle going to be doing in the next 10 years?
I'll tell you one thing. I don't know, but let's see. We had a new CEO of Global Dosimetry. ICM became Global Dosimetry in September 2003, and he became our CEO in April 2004. And we sat down and just talked, and he had been there for a few months transitioning us to the new company. And he was a non-physicist, but he was a good businessman. And he sat down with me and he asked me, what are your long-term goals? And I looked him right in the eye and said, you know what, at this point in my life, they're all short-term goals. I don't have any long, I pretty much aspired to where I really wanted to be.
Yeah.
I mean, I had the respect of the industry. I know a lot of people in the industry. I mean, you know, I come to this kind of HPS meeting and I can stand in a room and I probably see 100 people come by who know me.
Right.
I'm very prolific on radiation list servers, so people,
I know you are.
people get to know me.
Are you still going to continue that?
I will. So basically, you know, I told Tom, who was my CEO at the time, that, you know, I'm head of the technical operations regulatory worldwide for this company. You know, I probably don't know how many more years I'm going to work. I don't aspire to be a businessman. So essentially, I've really met my goals. Now, in 10 years, where will I be? Well, actually, where I want to be is I want to be working for National Geographic as a photographer. Basically, because that's my hobby. I do take a lot of pictures. A lot of people who go to the society meetings, they see my pictures. I take pictures of all the meetings. I take pictures wherever I go. I have about 150 picture pages on my website. So my real goal would be to become a non-working physicist, taking pictures around the world and letting someone else pay for the travel.
What has the Health Physics Society meant to you last?
Well, you know, for the first few years that I was a member, again, 1970, the focus of the society at that time was really, it wasn't geared towards the reactor physicists. You know, it was more oriented to government people, it was more academic. There's a lot of, I read a lot of studies on beagles, I read a lot of studies on uranium milling, dirt. So I didn't have a lot of interaction with the society at that time. As I joined the commercial world, and of course the society wasn't trying to go out and get a lot of reactor people either. You know, I mean, they finally created the reactor physics section mid-1990s, so it was a long time after I had joined. You know, 23 years after I'd been a member, they finally said, you know what, there's a whole bunch of people out there from the reactors who probably could help us in the society. But I stayed as a member, I supported it from 1970, and basically when I went to the commercial world, then I started to come to all the meetings. And I gained a whole new perspective at this point because now we had the reactor physics people, I was a commercial person. So I started to become more involved in the society, and my first big opportunity was to, at the request of George Anastas, who was president at the time, they wanted to have somebody come in and take over an ad hoc committee, the Electronic Media Committee. Part of the reasoning was the medical physics group had a listserv that was defunct, and the society wanted it to be running. So I said I would do it. And I came in, and within one day we had a listserv running for the metaphysics. I worked with several people at San Onofre who were computer whizzes, and we set up a listserv on the HPS1 website. And at that time, I started to think about what the society needed to become more like other meetings around the world that I would go to. And the first thing I said, you know what? We don't provide the membership, and again, the whole thing is, what do you provide your membership? Come to a meeting, there's no way to connect to the internet. So I came up with a plan. I recommended the board of directors that we set up these internet cafes at the meetings. I went to one of the board of directors meetings. This was probably 97, 98, 99, and proposed this thing here, very cost effective. And there were members of the board who came up and said, well, in the discussion, why would you do this? People can go to their room and use a computer. My comment was because most people have to pay 10, 15, 20 bucks per night to use the computer. And I said, but you know, the society needs to do more for their membership, and this is a service that would be invaluable. Cindy Jones, the NRC, was my board of directors liaison, and she kind of helped push. So we ended up getting that pushed. From there, I then joined the symposium committee, which was responsible for the mid-year meetings. And we, at that point, are the ones that came up with the first time where all of the presentations for the mid-year would be on PowerPoint. Because before that, people were using slides and overheads, and it was pretty archaic. So we...
I remember those days.
You remember those days? Okay, I remember those days.
They went too long ago, really.
So no, it wasn't that long ago. So we finally got that through, at least for the mid-year, any presentation would be PowerPoint. And then from there, I met Jack Fix from PNL, who was the chairperson at the time of the Standards Committee. And it was at the Virginia Beach meeting, the mid-year, that
I was almost snowed out.
Yeah, exactly. I got stuck on an airplane in Atlanta. I met Greg Comp from the Army. He and I were sitting. They were so, the airline was so apologetic. They put us in first class, and we met for the first time. That was great. And now he's a good friend and colleague of mine. And so Jack Fix nominated me to be on the Standards Committee at that meeting. I was approved. So now I'm getting to an area where it has effect on the industry. So that was important. Right. And after about a year and a half, I was appointed or nominated and voted on by the committee to become the vice chair. And then after the Tampa meeting, Jack was going to leave his term as chair, and he asked me if I would consider doing it. And I said to him I was pretty intimidated to follow him as a chair of that committee because it had a lot to do. And he said, no, you'll be okay, and I'll be a past chair, so we'll do it. So after the Tampa meeting, I became the chair, and I'm still the chair for another term now. And but I work with Joe Ring, who is the chair of N13. I work with Gord Lodi with N43, and even though N42 is not the Secretariat is not, from HPS is not involved with them, they're more IEEE, and I work with N42 as well. So I have an opportunity to see what's going on in the industry, trying to move new procedures, new standards. We had a conversation yesterday about environmental standards, and the U.S. unfortunately is behind a lot of the countries. We have a lack of standards in certain areas. One of my goals from an HPS standpoint, we just had that meeting with the President-elect, and the past President of HPS, is to become more involved with international standards. So we're going to try to come up with HPS standards, Nancy, that are more in line with ISO standards, so we can bridge the gap and stop being the outlier in the world as far as standards. So I'm at a point now from a career and with the HPS where everything is just about right.
So when do you think will be metric?
Never.
Here we are in 2006.
It's hard enough because we're dealing with the dosimetry part, you know, okay, we're talking about, all right, I can understand millisieverts, okay, I know that pretty well, and I can understand sieverts. Then we get into the becquerels and grays, and GDS has a lot of customers overseas, and of course all of their information is in the metric system, and we provide it, but when I have to go back and do a dose assessment or dose reconstruction, I'm trying to think, okay, how are they doing this?
Exactly.
I have a feeling that I'm going to basically be gone from this business before that becomes a real issue.
Right.
I sure hope so.
Well, it's about time to wrap up, and I just wanted to ask, is there any final remarks you'd like to make for the record as to the future of our profession and health physics?
I think the biggest issue in the future, and I think this has been recognized by a lot of people, we are now finally in I call the nuclear renaissance again. You know, since TMI, there's been no nuclear plant built in the United States. The rest of the world is going continually. They're building, France, Germany, had voted to shut their plants down, but they really can't replace it. Sweden had said they're going to shut down. They're starting to back off of that. Well, in the U.S. finally, there are 3 or 4 large utilities who are now going through site preparation, and they're setting up their procedures, environmental impact statements. So there are going to be new nuclear plants being built in the U.S. The problem we've had is that because there has nothing in the last 20-something years, that there have been, the schools have shut down a lot of the graduate programs. There's going to be a demand for new people. The NRC alone is already looking for 300 people. I don't know where they're going to get it. So while the demand's there, I mean, it's an opportunity for people to go into new areas, but a lot of us are getting older. Not only are there no new people coming in the pipeline, there are a lot of us who will be leaving in the next 3 to 5 years probably. So I think that's going to be the biggest issue to face in the U.S. If you're building 10 new power plants, where's the staff going to come from? With new medical procedures, where's the staff going to come from? I've been asked many times from students, this is years ago, what should I do? And my comment back then was, don't go into nuclear energy. You know, go into medical physics. You know, go into university RSO programs. So I think the future is bright, but the problem is where they're going to get the people. That's going to be the biggest thing to overcome. If I were starting out now, I think it would be a bright future again, but I'm ready to let the sun set.
Very good. Well, thank you very much this morning. I really
appreciate
it.
And enjoyed talking with you.
Fantastic.
Thanks, Jeff.
Thank you.